Wow, that was a lot of drama. Oh my God, guys. Uh, it's a love-hate relationship with the program that I use and many, if not most other people use called OBS. And that is the way it handles drivers and activating, deactivating cameras is extremely frustrating. So that is what I deal with, and it's usually absolutely stupid results in how to finish what I'm doing. The camera and then switch back. It's something completely stupid. Instead of just turning off a device and turning it on or unplug it and replug it like most people would troubleshoot, I have to do something like switch it to another camera, allow that camera to start to feed on that patch, and then switch it back to the original camera. Extremely frustrating because it honestly doesn't make logical sense. So anyway, I had to reboot my computer and everything. It still didn't fix it. So here we go. Anyway, I think we're ready to go ahead and switch to the overhead view, and we'll just start going through this theory of operation, and then we will talk about ice makers in general because they're interesting devices. They have a variety of different ways that they function, and the last one I took apart on this bench, it was very complex. To say the least, it was very complex. This one here is a lot simpler. A lot simpler. All right. So let's go ahead and let's flip to the overhead table view. All right, folks, and hopefully y'all can still hear me and everything. And I will, of course, be able to move the camera around stuff a lot better with this one. So this is the Frigidaire ice maker, and there are a whole host of ice makers just like this out on the market. And these ones here are about 1/5 the cost of the pellet maker that I took apart and repaired last time. These ones here are rather inexpensive. You can buy them for usually less than $100. And the ice bin is a lot smaller than the other one. It comes with a very cute little ice scoop. And here you can see my fluid reservoir. And the big show is inside there. You see these fingers? Oh, right up there. These right here are chillers. And you can see the tube that feeds from the top right there. And there's actual refrigerant that goes through those, and they frost like ice cold. And there's a tray. You see this tray right here? And this little shovel. So the tray is up there. It's inverted right now. And right here is the shovel. And what happens is these guys here will be sitting in the tray. It's like a scoop. You can barely see it right there. So it's a shallow pool of water that it fills up. And then these guys right here, based on your suggestions for small or large, you see right here, small or large, those are actual timers. So small ice cubes it will actually cycle faster, and large is it will cycle much slower. So it allows time for the ice cubes to grow. Now I'll show you how those are supposed to grow. So while these coolant tubes are sitting in that pool, they'll immediately start to frost and crystals will build outwards. And the longer they sit in that pool of water, the larger the ice cubes will get. And then what happens is it will shut off the coolant cycle, and it allows these guys here to defrost momentarily. It actually happens pretty quickly. And since these guys here are shut off, they de-seat the ice cubes, which fall down here into the basin. And that shovel is literally like a shovel. And it will scoop the ice here. So it does a scooping motion and puts the ice here. And you notice that it's got these 3 passages right here for fluids to run down. And that is because when it dumps the ice cubes, there's also going to be fluids that dump as well, because you're not solidifying the entire trough. So those cold fingers sit in the trough, they grow an ice cube according to the timer, and then it shuts off the coolant and it allows them to thaw a little bit around the metal, and that will allow them to de-seat, and it dumps them in here. then they get shoveled into the basket. Now, there are a bunch of these out on the market, and they will last a long time if people take proper care of them. And you're going to see some evidence right here. This one here was given to me for free. So I did not buy this one. And this is the gentleman who bought my last ice maker, the one that I completely refurbished. We went through and redid all the fasteners, and I drilled and tapped out a bunch of stuff, and we cleaned it thoroughly. Well, now we have this one. He brought this by my house and said, here you go, this one here is for you. So I'm making a video to show you guys and maybe help you guys, if you have one of these, to keep it from getting damaged like this. All right. So some of the first things that you should notice is that there is scale. You can see it right here. So this right here is your LED and receiver diode. So it's infrared. And when ice builds all the way up in the basket, it will block the path of light between this and this. And when that light path is blocked, then it will not generate any more ice because it thinks it's full. Now, it's possible, because I see scale right there, and I see scale right here on this one. It's possible, yeah, it's possible that those guys are really dirty, and to which this whole thing is going to get cleaned anyway. But I guess the first thing that we should probably do is a function check just to be sure. Okay? It's already dirty, so before we go and sanitize it, let's see if we have a coolant motor. We should be able to detect if the tubes up there are getting chilled. They should start to frost. I mean, I am in Houston, so there is going to be some humidity in the air, and you will notice it. So what I'm going to do is I'm going to get a bucket of water. And because I have not descaled this unit, this process is actually okay. The problem is that people are using these things without using distilled water. The most perfect water that you can use for one of these machines is going to be ultra pure, like reverse osmosis or distilled water. They should not use any other type of water because you will get scale. And a lot of this is residual. It's clear evidence that this machine has not always had the best water. That's okay. It could be fixable. All right, so we plugged it in, and now mind you, I just flipped this guy around, and there is oil inside the coolant path. That is not a good idea to be flipping it around and then turn it on immediately, but we don't even know if it works. So I'm gonna go ahead and turn it on. And as I turn it on, you can see the shovel right there. You see how it comes up and scoops the ice? It's a good opportunity to clean some of that out. Okay, and as it comes up and scoops the ice, the trough back there, which I wish I could show you guys, the trough is filling right now with water. So it's a two-part motion. It scoops out the ice and it dumps the water, which I just, whoops. Hopefully that's not going to be a problem. I just touched it and now it's dumping a lot of the water. So I'll tell you what, let's go ahead and turn it off. There is a self-cleaning mode for this thing. So yeah, it's going back down. The trough is now dumping out all its water and the shovel is coming back to its home position. So as the shovel comes down, the trough comes up and aligns with all those cooling heads. Now this guy, according to the manual, says it will make ice in 9 minutes. That is pretty fast, okay? That is really fast. But that's to be expected when you have direct coolant touching the water, you know, in those little metal tubes. So unlike some of the other systems where you have a cold pot, like the previous one that I did, it had a cold pot, and because of that, the pot itself had to chill. It adds to the time, but it does add to thermal mass, and thermal mass allows it to maybe be a little more productive. Okay, the trough is full, and it's up in its home position. Now, last time I touched it because I was goofing around, and since I touched it, it didn't like that at all. So no matter what happens here today, I am definitely going to clean this guy out, guys. Okay? All right, we have a chiller that just kicked on. So over here is going to be my condenser. working pretty good. The compressor is ultra quiet, folks. Ultra quiet. In fact, the only thing that you are hearing right now is that fan. Look at that. So it is a DC fan that is clicking on and off. Now, looking inside down here, I do have some evidence of water or maybe possibly slight leakage inside the chamber. But we're going to figure that out. We're going to pull it completely apart, guys. Okay, so the chillers are... Oh, that guy. Oh, it is definitely getting cold, folks. Definitely getting cold. Yeah, I've got ice forming right here. Wow, that is fast. There's already ice forming on the tubes. Yeah, I can probably pluck it off and get some little baby ice cubes. Okay, so after you touch that tray even a little bit, it does not like it at all. Okay, go ahead and shut it off again. So it can dump out. And then I'm going to pluck me some baby ice cubes. Why not? Okay, let's see. So it is definitely working, 100%. Come on. And here's the problem is during the cycle, it will shut off coolant to these tubes and it gives it time to deseat from the metal tube. But since I just shut it off, the water's frozen up in there. However, might be able to show you guys. Oh, can I? I don't want it spilling. Okay. Ooh, we're getting there. We're getting there, folks. Oh no. I can't do it any further. Oh no. I'll have water like dumping inside the machine probably. I shouldn't have filled it so full. But you get it. The little fingers are they do have a pocket of ice on each and every one of them. There you go. There's a little remnant of the ice right there. Okay, let's go ahead and turn it back on. Okay, it's cycling. So everything is working according to what I would hope. Now the only thing that I'm not really comfortable with is the fact that I barely touched this guy at all and it wants to dump and it will never reseat in its home position. And because it doesn't reseat in its home position, you'll never get full-size ice cubes. Like the tray is now at an angle instead of being flat, if you understand what I'm saying. So instead of the water line being like this, it's actually dumping some of it. Okay. All right, so it's filling up the trough again. Okay. It just melted all the ice because, you know, physics. All right. And just kick the chiller back on. I'm moving my menus around, folks, so if you wonder what I'm doing, this way here, I can interact with my cameras and show you much better camera angles of what's going on. Boop. Right, here we go. So right now, it is forming ice once again, and that is fantastic. Now, I do think that part of the problem is the scale that gets right here on these LEDs. So because the scale gets on there, it thinks that it's full, and thus it's no longer gonna create any more ice. It's waiting for that path, that light path to clear up, but it's never gonna clear up because right here, these guys right here, you see it? And technically, it should say right here, ice full when I block that light path, but it's not. It's probably because it's got to cycle at least, you know, a certain amount of time before it looks for that light path. Okay. Well, I do see some ice cubes forming again. And it's working. It's working, but it still needs love, all right? So what I'm going to do, and one of the reasons that I have this set up the way I do, because I can zoom out. Come on, zoom out. There we go. Now you can see my desktop and what I'm working with a little bit better. Okay, yeah, so I've got a camera that's way up there, and that's where you all will be observing me. So I've got some of these items here. I'm going to drain the water, and there is a drain spout right down there. You can see this guy definitely needs some love. That's okay. So in order to drain this guy, I'm going to unplug it. I'm going to bring it forward. Whoa, whoa, whoa. So there is a little bit of residual water. That's probably from me tilting it like a goof. And right here is my downward facing spout. So I'm going to go ahead and pull that and let it drain into the bucket. So for the most part, it's working. It's working all right. It's just, it needs love. Good stuff. Wow, that is such a weird little plug too. Come on. There we go. Lovely. All over my toolbox. Okay. You guys can see the water level going down. It's also a good time to get in here and get out any sediment that might be sitting in the bottom. That definitely helped. Looks a lot better down there. Okay, so step one, we're going to get it drained. Now this guy right here looks like just a strainer. See that guy down there? And normally those strainers, you can just pull them out. So I'm a little bit curious. All right, let's go ahead and seat this back. So now you guys can see why I have a silicone sheet down here, is because stuff happens, like oils, petroleum products, water. Yeah, easy to clean up. Love these silicone mats. Okay. All right, so very delicately cleaning up around all that. Check. Okay, so there could be water still in the heating and cooling track. Not really sure. God, should I invert it, guys? What are the odds I'm going to get water all down the front of me? Oh yeah, there it is. Come on. Let's see. Just a little. Ah, come on. Right down the front of my toolbox again. Goodness. Okay. Well, my ultimate goal is to flip it completely upside down so that you guys can get a good look at the fasteners that are going to be on the bottom. And right now I'm trying to find all my shop rags to make this process a little bit cleaner, guys. All right. Trying to do the right thing and be professional. All right, let's do this. All right, shop rags. It's going to be a huge help. Okay, so the cool thing about these shop rags is you can squeeze them out and reuse them. That's going to be a pretty big plus. The accessories, I'm going to set them off to the side over here. Do not need those anymore. All right. And let's go ahead and get a container for fasteners. I think they're mainly going to be the same size. How much more water has it got waiting for me? A little. Okay, so for you guys, you can see right here, we've got fasteners around the perimeter, and the shields come off in two different sections. So we have a rear shield and we have a front shield. We're going to go ahead and pull those guys off. And I'm going to go ahead and use a power tool. Now, mind you, this guy is currently working, so I do not want to take it apart to the point where it's no longer working. And the front shield. Right here you can see the spout that drains the chamber. That right there is clearly insulation fill port. Okay, so those shields should come off right now. Now I've got a power cord guide on the back cover. Let's see what else we got going on here. I've got a black cover here, and that almost looks like a multi-country adapter plate. So if it's going to Europe, it's going to have a different interface. I don't know. It could be the electronics, because this guy here might have a relay pack or something. Let's find out together. Wow. You can tell that these things, they're built for cheaply. It's the only way to put it, because if they're selling them for like $89 online, then that means that they have to be manufacturing them for what? $12, $15? I have no idea how they can manufacture them for that cost. But you got to remember, you've got shipping, importing, you got the retailer, they got to get their overhead. So it's just amazing that they can manufacture these things for what they do. Absolutely amazing, guys. Okay, so there's that little black cover, and all it was covering was the relay, or the start stop for the compressor right here. Okay, right, power cord there, very cool. And let's see, we have a solenoid right here. So that solenoid is for metering, I take it. So it's going to inject a certain quantity right here into something. What's going on? So it tees off. It goes from up here. Yep. So that's the metering device, this little solenoid right here. So if you've got cable or cooling tubes right here that are getting chilled, then my next step would be to come up here and manually activate that relay. Control panel is right here. Super easy to get to. Look at that. Nice. So we have one large contactor here. We've got, let's see, what are these guys? Okay, interesting. So we have some detector switches right here with a cam. And these are going to detect if the tray is in the up position or the down position. So they're limit switches, or just position detectors, more likely. And yeah, this thing is very simple. I still don't understand how they can make it for the price that they do. It's just absolutely amazing. Because, you know, you'd have to figure the compressor and all the copper and stuff. I mean, there's no way that they can make it that cheaply, right? Compressor looks like it's in excellent condition. It looks like some of the signs of leakage that I pointed out once before. It looks like it's just cumulative and maybe from drippages, you know, from people like me fill it the way I do. Okay, and let's see, up here, this is the fill tube. This right here is my rotator motor, and this guy here positions the tray. and it's a synchronous motor, of course. And down here we have a 12-volt fluid pump, and I do see in some of the hoses we have some signs of calcium deposits. You see it a little bit. So we are going to go ahead and take care of some of that. We're going to use a diluted version of CLR, and we're going to run this guy because it is a short cycle. So it's going from right here just up here to the flipper motor and then back down to the reservoir. So really short cycle of fluid, and that's okay. You know, that's going to make it easy for me, that's for darn sure. All right, so this guy here, I probably should just go ahead and clean out some of this. We don't want any residue floating around down in here. And that strainer, it looks like it should pop up. Come on. But it doesn't want to. So is it screwed from the bottom? I have no idea, folks. It almost looks like it might be screwed from the bottom, but you would think that that strainer would be removable so that you can clean it like in the GE unit. Anyway, the shovel right here, you see some of the condensation is building up on those coolant tubes. See it? So the shovel, it's in good condition. See it? It's got 2 joints. Yeah, all this has got to get scrubbed up and cleaned. So when I get a little bit of CLR up in here, I will paint it on with this. Literally paint it on. So I have a brush right here, and that will help us clean up some of this. So that's what I'm going to go ahead and do right now. Let's go ahead and pour out this water. All right, and I'm going to get a new bucket of water. All right. Now, the thing about CLR is it is an acid, and because it's an acid, you are going to want to dilute it, and you also cannot leave it on there very long. In fact, they say 2 to like 4 minutes is how long it's supposed to stay on there. Now, we could leave it on a little bit longer if there's heavier scale. This thing has really light scale. Gosh dang, they really put that cap on there, guys. Okay, so what I'm going to do, I'm going to put a little bit of water in this cup. Then we'll put some CLR in there. Okay, that is, I know it's going to be a strong concentration. So guys, because this is an acid, it dilutes well really easily. And actually on the CLR, it talks about using this for like showers and stuff. So if you say, oh my gosh, that shouldn't be around things that you're going to ingest. Well, that may be true. You know, obviously we want to limit a lot of things that we do, but CLR is very specific in that it eats away at calcium deposits, and it does so really well. And we're going to dilute this. We're going to wash it multiple times when it's done, and that will clean away any residual. So guys, you can see what I'm doing. I'm painting it on. Get up in all these areas. Underneath that shovel mechanism right there, there's a lot of deposits that are forming back and in here. See if I can get you guys a camera angle. See that right there? Underneath the shovel. There you go. Get a little bit more. And it's bubbling up like that because it's reacting with all those mineral deposits that are on every single surface in this thing. You guys have always seen the acid and bases, like baking soda and vinegar. This is kind of what we're doing here. Okay. You can see that it's been rubbing down there pretty heavily for a long time by the looks of it. So what we're going to do, we're going to use some of my plastic scrapers. Now, I've talked about these guys before because they don't leave permanent scratches in anything. But when it comes to debris on plastic surfaces. These things are phenomenal, guys. Absolutely phenomenal. Josh, good to have you, man. Good to have you. Got some people, guys. I am reading some of the comments, so even though I might not get to them right away, I will get to them. Thanks for watching, guys. Now, the interesting thing is that we do have ice makers like this in medical facilities. We really do. So it's something to be aware of, that you should take opportunities like this as practice, because we do see refrigeration systems. We do see ice makers. I mean, every hospital is different, of course, but we do see this kind of stuff routinely. Okay, so already a lot of the stuff has cleaned up. And gosh, to move this tray, so in order to move that tray, I had to plug it in. There we go. I'm gonna unplug it again. So what I did is the tray was covering all the cool heads, and I rotated it 90 degrees. So now the bucket is facing away from me. It allows me full access to get in there with my paintbrush and to clean it out. Oh yeah. It needed some love, guys. And there is some calcium deposits on the ice maker tubes, and the metallic tubes. Any resistance whatsoever to the ice defrosting is going to mean that the ice is going to be bound up on the tubes, and that is not going to be good. So this is good to get in there and clean up those tubes as well, any calcium that's built up. And I do have on that trough a lot of dark, like, is that where? I wish I can get you guys a camera angle. So dark spots, kind of like what I showed you guys right here in the bottom of the trough, right there. That is what I'm seeing up here on some of these upper areas of the bin. It's not calcium deposits, it's maybe just wear. Yes. Right up in there, real good. Let's go ahead and give it a splash. Okay, so what I'm going to do is I'm going to allow this thing to pump some CLR through all those tubes. So that's why I am kind of being a little bit dainty, but not, because we're going to run it. We're going to let this guy just run its little heart out. Okay. Go, just like that. All right, good. Okay. Boop, boop, boop. All right, who's counting, right? It's a little bit of an estimate. Good. A lot of that up and inside there is already looking amazing. Okay, so let's go ahead and turn it on. Let's allow it to cycle. Yep, there it goes. I've already gotten a lot of that right out of there, guys. Fantastic. So all I'm doing is getting my brush up next to the tray. Oh. Okay, here it comes. Here comes the shovel. See it coming up. Let's clean off any debris that's on there. Underneath. And there it goes. It's going back down. All right. So a lot of people will use things like vinegar, and vinegar will also do some of this stuff. But when you've got problems with stuff up in tubing, CLR just works a lot better. Okay, here it goes. It's filling up the trough as we speak. And now that motor okay. So it's cycling And I think it's cleaned itself, guys. Which I'm digging it, because that way there I didn't have to put it in cleaning mode. Okay, here it comes back down. It's going to flush it again. Oop. Okay. So that bucket right there is rotating up and down. All right, it's filling it back up again. Now I can see the suds building up in the trough. So it's cycling the CLR now, full on. Good stuff. Let's get up underneath there. Nice. Okay. So I don't want the chiller to run, so that's why I shut it off. I just want it to cycle that fluid back and forth. All right, I got almost all the dark marks off the side and off the front right here. It's looking really good, guys. I think I've got an ice maker that's almost up and ready to go. Now, mind you, I said that this stuff is kind of like an acid, so we can only use it for so long. So that means that I'm gonna have to get up in here with some water and start flushing it out. That's why I'm kind of working a little bit fast here. Let's go ahead and turn it back on. Okay. Bucket's coming down. Come on, come on. There's some sediment that I want to clean. Ayah. So before that bucket wasn't latching too well. Now it is latching like firm, and I can't even push it down. That's a good thing though, guys. That's a good thing. It's just kind of irritating because now I can't get my brush in there. I want to get my brush up in there. Interesting, you can see the LEDs on the camera, they're flashing, but in person they don't look like they're flashing. It's the camera refresh rate and the LED driver, because LEDs are flashed on and off. They're not permanently powered on, guys. Okay, all right, let's see. Got it. Let's go ahead and shut it back off. Get it. Okay, I got all the dirtiness out of that tray, and all those cold fingers, they are looking fantastic right now. I think we're ready to start my flush. Okay, let's go ahead and move the brush back. Got to wash everything out, guys. And now we have got to drain it. Do it. Okay. I unplugged the unit now. I'm going to pull it way off the table because last time it kept draining and wanting to hit the table. Let's see, can I move this guy? Yeah, I can. How about that? And this will be just great. Come on. I do not like this plug, guys. I don't like the plug. It's kind of a little bit of a pain. Okay. So this is all our CLR water draining out. And then we're going to run like 5 to 10 cycles of fresh water through it. And the last couple cycles are going to be distilled water or reverse osmosis water. There we go. Okay, I think that's about all. Okay, let me check it. All right, let's see. What do we got? What do we got? Dang, almost all that corrosion came right off those cold fingers, guys. Nice. Come on. Now all I'm doing is getting out any sediment that might be floating around up inside it. You can see the cold fingers way back in there. What I'm doing is getting my brush and cleaning off all those cold fingers. Any sediment that might be stuck to them lingering, I want to get it all gone, guys. Okay, ready? And just let it drain. Quite the process to clean these guys out. Now this unit here, thankfully, isn't nearly as complex as the GE unit that I just did on one of my last videos. That was seriously a pain. That's all right, guys. It's all right. Okay. And now I'm going to fill up a bag. There we go. Oh, come on. Stupid plug keeps getting back in the stream. Okay. There's our first bag to flush it. Thing I like about the bag is I can squeeze it and create a lot of flow. And the flow is what helps get rid of all the little sediment that might be stuck up back up in there. And there was some. I still see a couple of small black dots. All right. All right, that looks like it took care of almost all of it. Fantastic. All right, I'm gonna flush a couple more down here in the bottom trough. Get that foam out of there, because I don't want to be cycling the foam back through the machine. I want to start flushing out all that CLR. Dang, that looks really good. Let's see. I had some evidence of scale up here. Let's see if I can get, yeah, a little bit. Over here. Yeah, a little bit. Very cool. All right. And let's see. So all I'm doing now is breaking up some of the larger sections of calcite that was kind of deposited up in there. I'm trying not to allow the screwdriver to dig in. There we go. Just break it loose now that it's usually softened up by the CLR. Beauty. Okay, my cooling tubes look like they're really good. Let's see. Excellent. Okay, let me lay a couple of these tubes down. Oh, nice, guys, nice. So I'm looking over here at the tubes that were full of, well, no other way to put it. They're full of deposits. They're completely clean right now. Completely clean. Look at that. That's phenomenal. So now we have to cycle some water through the machine. So we're going to cycle water, then drain it, and then cycle water, and then drain it. Okay. So plug is back in. Let's go ahead and fill it up with some more water. All right. Okay. We can go ahead and plug it back in. All right. It's going to cycle the trough. All right. Here we go, guys. I do have a little bit of scale right here that the CLR did not take off. We'll get it. Okay, I think they got a lot of it. Nice. Okay. There's now cycling fluid around those cold heads. That's good. Okay. I don't want it to chill, guys, so we're going to shut it off. Let it dump the water. And then we're going to do it again. We're going to refill it again. Okay. There we go. You can see anytime you're dealing with these kind of products, it can be maybe a little frustrating because it's repetitive. All right. I don't have the smell of CLR anymore. That's good. It's kind of a sugary type of smell. Let's see. My drawers got some water in them earlier. I don't keep very much in these drawers because, you know, stuff happens on this table. Okay. All right. And there's that one. Let's refill it again. So now what I'm doing is I'm flushing out the pump and the coolant tubes, making sure that they all stay nice and cleaned out. All right, let's do this. All right, there's one. There's two. Okay, and now I'm going to plug it back in, and we're going to see it cycle the fluids again. Here we go. Power. Okay. Man, I'll tell you what, that motor is much, much smoother right now, and how it comes up. Yeah, finds its home position. Much, much smoother. Okay. I do want to clean out a little bit of that tray. I can see some stuff up in there that's bothering me. All right. Okay. Yeah, so I need that tray to be partially at an angle to clean it out properly. There's just some small black specks up in that tray. Okay, ready, set, and right there. So in other words, I need it to rock down just far enough underneath the cold tubes that I can get my brush up in there, just like this. Scrub away any of that residual that's going to be up in there. Let it dump out. There we go. Let it finish cycling. Okay, comes up to find its home position and goes all the way down. Nice. There we go, folks. There we go. Okay. I think I got all the specks off it. You can see some of the little dark pieces that are flying in. There we go. All right, let's go ahead and turn it on. Let it home, and then it'll refill. Thanks, Josh. It is looking good at the moment. So I've got a little bit to do with the stainless steel on the outside because it looks like, yeah, you can see the stainless steel on the outside is not looking too fantastic. So I got to clean that up. I don't know how I'll do it. Maybe isopropyl. Guess I'll figure it out. Let's try some sanding wipes. Sometimes those work. Yep, they do. So hospital wipes, they're working pretty good. Look at that. You see what I'm looking at there? That was on the outside of this case. Wow, look at all that. I have no idea. You'd almost think that this was in a smoker's house based on the kind of tarish residual that I'm pulling on the outside of the stainless steel. I don't think these guys smoke. What a cool project though, guys. I'll tell you what. So here's something. When it comes to cleaning stainless steel, and I wish I could rotate this a little bit so that you can see it. So when it comes to stainless steel, there is a grain pattern. You can see that the grains are going in this direction on this panel right here. So while you can use circular motion to kind of scrub at it, eventually you have to go with the grain. Just like that. Let's get out of here. And you got to go with the grain, and that's how you'll get all the little imperfections, kind of rub them out and clean it up proper. Look at that. It's going to be beautiful. Now, my overall goal is to give this back to the gentleman who gave it to me for free, and tell him, hey man, it's good to go. You should come pick it up. Because I honestly don't have too much of a use for an ice maker. It makes for a cool project and a cool video. But in the end, I don't have a use for it because I have a ice maker on my fridge. There we go. Look at that. You can see the stuff that I was talking about right there. And these wipes are cleaning it out. Like that. So it is coming out. It's just, you know, takes a little bit of elbow grease, right? And let's see, how are we doing on the ice? So our chiller's running, and I think right now it's currently making some ice. go. What a cool project. See, I just have a little bit right there now. This thing's going to be like brand new. I still am baffled at how they can sell these things for like $89. That's amazing, because it does have a whole refrigeration circuit in it. Let's see. So the thing about stainless steel is anything where there's a lip, it's where stainless steel always has got the most corrosion. And you got to watch around stainless steel not to use bleach, because bleach will eat through the nickel oxidation that's on the very outside, which is what gives it that shiny and stainless steel part of being stainless steel. And once bleach eats through, you'll get little pits, kind of like right here. See, there's a little tiny pit right there. And bleach will do that really quickly. So do not clean stainless steel with bleach or bleach wipes. That's some bad juju, guys. All right, man, this thing's coming along quite well. I like it. Excellent. So I got a little bit of a time delay anyway for this guy to start chilling and making some ice, which it is. I can clearly see the ice building up. Very cool. It's just amazing that engineers have the same problem and they have different ways of making a solution to that problem. In this case, they simplified the production. That's why there's so many more of these in the field than there is the GE Opal ice maker. It's because these are 6 times cheaper. And there's minimal moving parts in them. Technically, this should be a very reliable unit. But, folks, you know, with cost comes cost-cutting measures. And also, the users. The users are the #1 problem with even medical devices, guys. And whenever you have a device, just remember that try to use the most pure substances you can with it. In this case, reverse osmosis water is what I would instruct the family to use, because RO water, it doesn't have the mineralization in it to build up. And once you start getting build up, it creates problems all over the place, for sure. Look at that. Beauty. And I am all too happy to keep a unit from going into the waste, especially when the refrigeration system's working. I mean, how crazy is that? I have a full compressor, evaporator, and condenser right here. It's all here, and it's all technically working. Well, actually, the evaporator isn't what you think it would be. It is actually those cold heads, those fingers. That is technically your evaporator in this unit, but nonetheless, it's still there and it still works. So just because there's a cheap plastic part that broke or something, man, that would be an absolute crime to throw this away. There we go. That is looking phenomenal. Okay. So it's going through a little bit of a cleaning cycle, it looks like. Let's see, we're large. Small ice cubes. And let's see, I got no warning lights. We're good. Got those little fine black specks off of it. Okay, so this panel right here is clean. I'm going to set it off to the side right here. And while it is going to be making some ice, I'll just clean the front of it here. A buffer wheel or something would make this so much easier, guys. Right, all right. All right. Okay, what do we got? Put my fingers up in there carefully. Oh, that's interesting. So this is a reversing cooling system. Is that what that solenoid's for? Some of you guys probably figured that out already. It's a heat pump. So a heat pump is when it reverses the coolant, so the condenser and the evaporator essentially switch sides. And that would also make sense why it can make ice so fast, because the ice attaches itself to the fingers, and what it does is it reverses it with that solenoid. I thought it was a metering solenoid. It's a heat pump. So it heats up the fingers, and that melts the ice around them and makes the ice drop down into the basin. Goodness. I should have known that, guys. Yep, the fingers right now are really warm. And of course, over here, my condenser is cold. It's a heat pump. How cool is that, guys? I absolutely love technology. Okay, well, there you learned something. It also uses that for its defrosting, which is technically what it's doing right now. It's defrosting itself, making sure it's good to go. Okay, let's go ahead and shut the power off. Then I'll turn the power back on, and we'll run it into a cooling cycle. I'm just sanitizing some of this stuff up here that I was touching and whatnot. You know, a little extra step. Cleaning everything. Very good. Okay. Let's unplug it. Plug it back in. Okay. Now, one thing that this guy might not like is the door being open. I don't know how good the IR sensors are right there, but if it's receiving infrared light from over here or over there, then it's going to think that the ice bin is, well, if it's receiving light, then it's going to think it's fine. But if we block that light path, it's going to think that the ice is full. There's a little bit of residual down here. You can see it. I want to clean that out as well. How's our tray? Okay. All right. Compressor's on. I got my fingers up here on the cooling tubes so I can see exactly what they're doing. And it feels like they are warming up at the moment. Yep. So it wants to go into a defrost cycle right now. And I want it to go into a cooling cycle. Okay. Well, this guy here is clearly going to do what it wants to do until it satisfies that it's been defrosted. And then it will go ahead and probably go into a cooling cycle. So everything is working really well. And the movement of the motor, I was initially worried about that motor right there because I barely touched it and it would fall basically, and the tray would be only half full because it was at an angle. But taking the covers off and cleaning it, now it seats itself thoroughly and it looks to be happy. That's cool. Very happy to hear that. All right, so this thing right here, as far as I can tell, it's going to be working. I just have to put the covers back on it. The calcium deposits that were in all the tubes and probably in the pump, that stuff is all gone. Very good to see. And it would be crunchy calcium deposits too. No, it looks like it's good. Phenomenal. So folks, what I will do next, and I'm not gonna do it right now because I need it to cycle, is I'm going to take a little bit of the CLR while it's powered off, and a lot of this garbage that you see down here, I'm gonna go through and make sure that a lot of this stuff right here is cleaned up, and then I'll rinse it off and make sure that there's no corrosion down there. Then I'll put the covers back on, and this guy here is going to be good to go. Yeah, I can see it forming ice right now. So it just needed to cycle a little bit on defrost, maybe because it detected power off and it wants to get rid of all the old ice cubes. And now it's going into a regular cooling cycle. Let's make some large ice cubes here. So anyway, guys, that is it. I mean, I was expecting a full and complete teardown, but on second look, the motors are working, the irrigation pump or the circulation pump, it's working good. Even my solenoid for the heat pump, the crossover, it's working fantastic. Yeah, look at this. Hot dog. So there you have it, guys. I'm gonna go ahead and move this guy over here and let it do its thing. It's nice and quiet, so that's a good point for us. All right, let me clean up my space a little bit. I have something else to show you guys. I'm always working on some cool stuff, and I've got a pack to go out to California in just a couple minutes because tomorrow morning, early in the morning, I gotta head out to Cali, Southern California. Look at all this. All right, my fastener's back there. We're going to be touring some hospitals, some companies. It's going to be some good stuff. Basically, checking up on people in Southern California that I haven't talked to in a long time because it's right before the holidays and right before, 2026. We're going to go around and see what's happening, get a little bit of feeling for the California market. And then later on in the week, I'll be back here in Texas, living life and getting ready for the holiday season, right? There we go. Nice and clean. Let's put the cover on this. Okay. I'll show you guys the other thing that I've been working on. Okay. So if you guys hear some ice dumping out, that's what's causing it, is this guy. All right, let me bring this tank over. This is a super cool project that was inspired based on a conversation I had with somebody. Okay. Let's bring him completely over here. All right. All right, scanner. Let's see. I'll put it sideways. So this is a barcode scanner. And this guy right here is a game that I designed from scratch. And I did so with AI. To be honest, it helped me through each and every step of the way. And I just wanted to prove the concept that AI can help us do things that we normally wouldn't do. Now, I haven't coded for like 20 years, guys. I'm 45 years old. I haven't coded in a long time. Might have been even like 25 years ago. So I used to know C and Turbo Pascal and obviously Basic, Visual Basic. And I used to do a lot of that stuff back in like the 90s and early 2000s. But then life happened and obviously I became a biomed. And in doing so, I had no more time to code computers and play around. So now that we have AI, it helps us with this very thing, and it's so cool. So anyway, inside here is, I don't think I've opened it for anybody to show them what's inside it yet. This would be my Arduino Nano, and believe it or not, there's a lot of stuff inside here, and it's going to look like chaos because it is. It is chaos, guys. So don't make no mistake about that. Here, hold on, let me move my stuff around so I can see what y'all are doing. Got 3 monitors here, and I'm trying to keep track. Okay, now I've got you guys right here in front of me. I can see what y'all are saying and stuff. It was like 2 monitors away. All right. So this box right here is the brains of the operation. And it's also, I have a buck converter in there, and a buck converter is basically like a DC to DC converter. It changes what is 6 point something volts, and it turns it into a more useful 5 volts for my Nano. All right, let's see it. Okay, I told you it looks like chaos on the inside. Okay, so my display is up here. Ooh, hold on. I've got a seal that wants to pop out. I guess it doesn't really matter because it's not like this is a waterproof box. But anyway, right here's my Arduino Nano. Right here is my DC to DC power converter. And I have yet another breadboard interface right here. And it's technically also a power rail. And my display right here, it's wired down to the Nano. And I have a relay down here, which is triggered by the Nano to turn on and off my, this is a 6 volt DC pump, air pump. So you can see I need 5 volts for this. My scanner needs 5 volts. My, my pump needs 6 volts. And that's why I have this trim pod or adjustable DC to DC converter. So I have 6 point some volts coming back there, comes in, it goes into a switch, and then you can see right here, I put ferrules on the ends of my cables, and I was able to plug them into these pinch strips, and this is one single bus, so this is all my positives. This would be my incoming positives, and you can see it's coming through my switch. So when I turn this off, it shuts off the entire thing. I turn it on, it turns on the whole thing. And then I have one of my my pinch connectors is for my negative. So it's a common negative across all my devices in here. And then I also have here a negative for my main power rail. So we got a 5 volt power rail and technically a 6.5 volt power rail. And from there, the heavy lifting is going to be my Arduino Nano, which is right there. So here's a air release solenoid, and down here I've got an air pressure sensor. So you can see them right there. Air release solenoid, air pressure sensor, and I haven't utilized both of those as well as I want, but the cool thing about using Arduino is I can come through, and let's say I want to change the rules of my game. I can change the rules at any time I want by just connecting up to my USB and telling it what my new code is, and the AI will spit out what my commands are, and it makes it good to go. You know, it programs my Nano for me, and I'm ready to play a new game. This guy over here, this potentiometer is adjustable contrast for my display, and I'm thankful for that because it's definitely needed. You know, various lighting conditions and stuff mean that I have to adjust that pot sometimes. But yeah, that's it. And then I wired up my connectors. So I've got a screw down connector. It's a 5-pin for my scanner, and it is keyed, so it will only go in one way. And this is my air output for the balloon. Now, I have played this game with several people already, and I will tell you this, it's extremely unpredictable. And that adds a very interesting element to the game because the balloon itself is a playing piece. And since all balloons are manufactured to different tolerances, you know, because the latex might be thinner or whatever, you are going to have different pressures for every balloon. Certain ones are going to give way like unpredictably easy, and other ones they're gonna grow huge, and then eventually pop or fly off. I've had them fly off too. So the gameplay is extremely unpredictable. It makes it very fun. And as you get to the further levels, like when the balloon is really full and you're really praying for like a smaller card, like 1 or 2 seconds, something like that, you pull like a 9-second card and it inflates another 9 seconds of air into the balloon and it still hasn't popped. It gets very suspenseful, guys. And I played it with all my kids and everything, and they're they're afraid of it because the balloon pops randomly, and then at the same time they're eager to play again. So they're like, hey, can we do it again? And I was like, yeah, we can do it again. I'll show you what it can do. Let me go ahead and put that screwdriver back. Okay, so let's go ahead and flick it on, and let me see. There we go. Hopefully the camera can read that now. And that's why the adjustable contrast, which I wasn't going to put in, but ChatGPT suggested highly that I utilize it. Good thing it did, because in other words, I wouldn't have put a pot in there and wired it up and gone through all that hassle. So the way the game works is each player is going to have a set quantity of cards. Okay? And the cards are going to be at random because they're QR codes, and you never know what a card is going to say. And when you scan it, it's going to decipher what the card is. And like this one here is 12 seconds of air. That balloon could pop at any second, and I would technically lose. So at any second, it could pop. Probably won't, but any second it could. Then the next player goes. And right here at the beginning, it's not so stressful. Yeah, like this one's 10 seconds. You're like, oh my gosh. Well, at this stage in the game, it's nothing. But you get like 10 cards in or so, and that balloon's starting to look pretty volatile. Here we go. And sometimes you'll actually get a card. See if I can find one. Sometimes you will get a card that will actually release air. Ah, 11 seconds. Okay. Let's see if I can find a card that's going to release air. Now, after playing for a while, I recognize certain patterns inside the QR code, so I know what cards are going to release air. Okay. Let's see. Let's go through this stack. Right here. Let's try that one. Oh, there it goes. So one of the things I was looking for is down here, there's almost like a circle in between the two squares. And that kind of told me, oh, by the way, that one there is a negative card. It's just how QR codes work, right? So anyway, there you have it. And that's the name of the game. And it will go and go and go until this guy either flies off or it pops, to which that person loses. And if I was going to make this a drinking game, whoever loses has to take a drink. And then you go on to the next one. And obviously, since you never know when it's going to pop, and it is technically, it's pretty random, I'll tell you guys. You think that balloons are pretty similar, they are definitely not. Like some of them will pop at this size, some of them will pop when they're like that big. You never know. See, this one's only 5 seconds. That would be a very good card if I was playing against somebody. and it's going to get really big. This balloon's going to get like that big. So there you have it. That is the game that I designed. I'm sure that this is more so just taking a whole bunch of principles and utilizing AI and learning how to guide AI to what I want. It is a learning process, guys, because like this guy right here, the scanner, it utilizes UART. And UART is a communication protocol, kind of like serial communications. And I had to learn about UART protocols and stuff in order to do this, but it was super easy with the guidance from ChatGPT. Even wiring in the contrast adjustment for this, I don't think I ever would have been able to wire in this display. It would have took me so long because did you see how many wires are going to this guy? It's like 6 to 8 wires going to this display right here. And also, to hell with that. Like, now that I got the wires connected and I figured that part out, now how do I figure out how to write text on this guy? That would be hours and hours worth of my life just to figure out those little problems. And ChatGPT writing code made it so easy. And it says, here's the Arduino, connect this to pin 7. Here's for D2, here's for D3. And it just tells you all the pins and what should be connected. And that's why I built it around a breadboard, is because it allowed me to make those connections rather quickly. Breadboards, by the way, are very cheap. So yes, I could later on make all that stuff that's going on in there. I could make it on a little board probably that big. But at the moment, just utilizing a breadboard and gluing it down afterwards so now it's permanent. Best way to do business. You can also see it has a little zeroing screen and title screen. It says QR Blast. Right there, QR Blast initializing. And that says zeroing the pressure sensor. So there's some cool stuff that I can do with this, and I made it so that it's upgradable in the future. So that it has a pressure sensor in there, so it knows how much pressure is going on in the balloon, and it can detect if there's sudden loss of pressure, which obviously means you win or lose. Either the balloon flew off or it exploded, to which you win or lose based on that. And with a release solenoid, that means that while a lot of these cards right here add air, some of them take air out, and that opens up a whole next level of tension when you're playing and that balloon is fully inflated and your opponent gets a air release card, and you're like, gosh darn it. It's really kind of crazy, guys. So that is QR Blast. It's a fun little game. It was fun learning about the intricacies of scanners, programming scanners, and then programming Python for my Nano. And it also helped out with things like this display, which I've never done before ever. I've never connected one of these LCD displays before. So how would I ever know how to write graphics on it? It just helped me every step of the way. It's super cool. Now, it doesn't take away from being a technician, because obviously there are certain things as a technician you still have to learn how to do. Like this one here, I created a pinout from my scanner, made sure that my wires are going to the male pin connector, and then from there they have to go to their correct sections on the board and or buck converter. And if you don't know electronics, that would have been very difficult, but it was still a cool project. And I think one of my next projects after this one, I kind of want to do a I'm thinking like a skill crane game, like the claw game, and maybe I will do something where instead of giving out a toy, it does something else. We'll figure it out. It'll be super cool. But this gave me a practical application of learning pressure sensors, triggering for the release solenoid, connecting using transistors. I trigger that the solenoid for the air pressure pump or the relay. So in order to trigger that, I had to connect a NPN transistor. It was a hell of a process, guys. And what a fun process at that. And the fact that ChatGPT walks you through it, and it's like a conversation, like a mentor sitting over your shoulder. And You know, the worst thing when you get into a project is when you say, what if? Like, you see what you can do. Now you have this idea. I now want to change something. What if? And the cool thing about that is ChatGPT says, yeah, that's no problem. I had a what if when this was pretty much all done. And I said, can you make me a diagnostics program that utilizes the player button that allows me to activate the pump for 3 seconds, to release air for 3 seconds so I can test out each of the functions to make sure that they're, you know, wired in polarity correctly and that the timing's correct. And also the scanner, to a diagnostics program for the scanner, and to read what the scanner thinks it's coming through. And it said, yeah, I can do that for you. And it went through and it created a program that is a diagnostics program. And I just flashed the nano, and every time you push the button, it cycles through a new thing. Like, it's going to run the air pump for 3 seconds, and then you press it again, it cycles through the scanner, it makes the scanner run, and then whatever's under the scanner, it will tell you on the display what it read. And then it can also tell you the voltage levels and stuff for when it's running, in case there's a voltage sag. It can detect that. It's such cool stuff, guys. So the fact that I had a what if, like, hey, now that this is all wired up and it's figured out, can we make a diagnostics program to test it? And it said, yeah, I can do that for you. And it just did it. And it was fantastic, guys. I'm so happy with the way that this happened. And I'm going to be doing so much more stuff with Arduino. And my first project was that vacuum packer, that vacuum sealer for doing meat. And the CPU broke on it. And I did a string of videos where I learned Arduino for the first time ever. And that was very fun. That was extremely fun. And I learned, holy cow, I can do all this stuff. And it just opened the possibilities. So this is my second project. I've already got a third project waiting. It's just waiting, guys. As soon as I get back from my trip to California, I'm going to start working on my third project. But anyway, guys, thank you very much for watching. I appreciate you. And stay tuned. Guys, if you're in Southern California, let me know. Maybe I'll stop by your hospital. And if it's not currently on the list, maybe I'll add it to the list. I'm always looking to see new things and meet new people. So let's absolutely do this. So San Diego, Southern Los Angeles, which is going to be Long Beach and Laguna. I'm going to be going all through those areas. Can't wait this week. Tomorrow morning, I'll be there. I'm pretty excited. So thanks for watching, guys. And just wait to see what I'm working on next. I got some projects right over here that will blow you away. It's new and larger things for this channel, and I'm very excited. So see you guys.